morning, students. Today we are going to discuss. Last class what we did? We are discussed about the independent events when it is given statements. Already you have given values. That values only we did it. Today we are going to do in working problems. In given in work problem means how to do it. So that is the first thing we will do now. See now, working problem means, as I told you, I cannot write the total problem here, but I'll show you some, I'll tell you some problems, I'll read it, and again if you have textbooks, you just follow it, otherwise again you have to do here only. Okay, so that is the first thing we are going. I'll read this problem, we'll start these problems now. So a box of oranges, we'll do like that. A box of oranges is inspected by examining three randomly selected oranges drawn without replacement. If all the three oranges are good, the box is approved for sale. Otherwise, it is rejected. Find the probability that a box containing 15 oranges out of 12, which 12 are good and 3 are bad ones, will be approved for sale. See, after reading the problem, first of all, what is given, what is asked to find out, first of all, you should know, read carefully. He said there is oranges in a box. In that box, total are 15 oranges are there, provided 12 are good oranges, means 3 are bad oranges. Whenever you want to sell these one box like this, means all good 3 good oranges must be there. If you do all the 3 good oranges probability, then the box will be, can sell out. Otherwise, you cannot sell out. That is what he is saying now. Okay, that we have to write into proper form and we have to do the problem. Okay, anyhow, now, so first of all, what is there? A box of oranges is inspected by examining, like that is there. So now, how many oranges are there? You tell me. 3 oranges we are taking out. See, a box of oranges is inspected by examining 3 randomly selected oranges drawn without replacement. First point is that. Drawn without replacement. What is that? First 15 box oranges are there in 15 numbers. He took 1 orange. Okay, it is good. He kept outside. Again he has go for second draw. Again that second orange also kept outside. Then he go for the third draw. So like that he is doing. And whatever the orange is drawn first, again is not replacing the box. He is keeping out like that. That is called without replacement. If without replacement if you do, then what is the probability of getting the box should sell for it? Sale, when you will sell, it should not be rejected. When you don't reject, all the through good oranges comes means. So we have to find out probability of 3 good oranges. Without steps I can tell you within 1 second. But we have to write the steps. So first of all, 1, 2 problems if I do means remaining problems you can do. Correct or not? So first, there are 3 oranges are there. So 3 oranges means first of all what you should write? Let A, B and C be the respective events. I will write now. How to write first of all? Let A, comma, B and C are respective events let A, B and C be the respective let A, B, C and B, here I write, let A, B and C be the respective events, like that. Respective events that the first, second and third drawn oranges is good. What is that? That first comma, second, second, third, and third drawn oranges are good, and third drawn oranges are good. That is the first we wrote here. So what we are doing first we have to explain. So there are three events are there. Event 1 drawing first orange, event 2 drawing second orange, event 3 drawing third orange. What we named it? A, B and C. That's why here what he wrote, let A, B and C be the respective events that first, second and third drawn oranges are good. What type of oranges you want? Good oranges only you want, all the three cases. So that's why oranges are good. That is we wrote it. Now, see now first of all one by one we'll see. The probability that first drawn orange is good. I'll write here. The probability that first orange is drawn good is otherwise first orange drawn is good, and like that also you can write, no problem, whatever meaning you can do it. First drawn orange, otherwise you can say like that also. First drawn orange is good, like that. Better kada? The probability that the first drawn orange is good. That implies. What is first drawn orange name? P of A. What is its probability? Now you tell me. In a box how many oranges are there? 15. How many good are there? 12. So first orange you should get good means how many ways can you select? 12 C1. Out of 12 you have to select one. But total how many are there? 15. This is N of E by N of S. You know it probability. I need not tell you. So this is favorable events. This is total. So first of all what you will do? The box is there. The box containing 15 oranges. So you are going to put hand on it. How many oranges will be there? 15. Out of that one should come. That is called N of S 15 C1. The condition is what? You should get a good orange. How many good oranges are there? 12. Out of 12, one orange can be drawn in how many ways? 12 C1. So therefore 12 C1 by 15 C1, which you can write as 12 by 15. 12 by 15 means 3 by 5. Correct? Otherwise 12 by 15 only keep. 4 by, other simplified, 4 3 is 12, 5 3 is 15, 4 by 5. 12 by 15 means 4 by 5. That is the probability of drawing first, like that. Now the probability, same. The probability that second drawn orange is good. So how much will come now? This implies P of B. So second drawn orange is good means what will happen now? You have to see now. So the first which orange is drawn, he kept outside. So the total number of oranges are only 14. So therefore in denominator 14 C1 will come. Out of 14 one orange you are getting. So 14 C1. In the similar manner, how many oranges are there in here numerator? There are, how many oranges are there means here 14 is there means total good oranges will 11 C1. Why you wrote 11? Already in first draw you took out one good orange. Therefore how many good oranges are left over? Only 11. So out of 11 one good orange come, and total also 15 one gone. So therefore 14 C1. So therefore it is nothing but 11 7 by 14, 7 means 11 by 14. In the similar way, the probability, I will write it, the probability that third drawn orange is good, this implies P of C. Third orange also good means 10 will be left out because it is not keeping 10 C1 by 13 C1, which is nothing but 10 by 13. So one event, what is the probability we are finding? First if we draw 12 by 15. Second we draw because ball is not replaced, orange is not replaced, therefore it is 11 by 14. Next third one is 10 by 13. Like that all good oranges only you are drawn. So therefore finally what? You want the probability. So the required probability. Required. What is required probability, you tell me? Getting required probability is getting nothing but all three are good oranges. All three are good oranges. All three are good oranges means what is the problem? Simultaneously you are drawing, one after the others. So total how many events are there? 3. So each event is happening simultaneously according to the fundamental counting principle in permutation combinations. If 3 events happening simultaneously, what you will do? You have to multiply. So like this, required probability, all three are good oranges. This implies P of A into P of B into P of C. That's all. Which is nothing but what is P of A? 4 by 5. What is P of B? 11 by 14. What is P of C? 10 by 13. Now simplification. 5 2s are 10, 7 2s are 14. I think nothing will go now. 5 cancel here, 5 cancel. So 4 11s are 44 by 7 13s are 91. So therefore 44 by 91 is the probability of getting, okay na? The probability of getting good apples, good oranges. So therefore what will happen? What is said now? Approved for sales. Approved for sale means all good must be there. So the probability of approved for sale condition is 44 by 91. Cases is this. Chances are 44 by 91. Okay, more than 50% is there. So therefore chances are there for approval. Okay, so first of all we should write like this. Otherwise I fire directly I can write 4 by 5, 11 by 14, 10 by 13. But you won't get marks. Your PU level, this entrance means only simple, easy to explain. In PU means you have to write each and every term. So 4 5 problems if I explain you can write on your own. That is why I wrote, let A, B and C be the respective events that first, second and third drawn oranges are good. The probability that first drawn orange is good implies P of A 12 by 15, 4 by 5. I told you total are 15 oranges are there, good ones are 12. That's why 12 by 15. The probability that the second drawn orange is good, P of B 11 7 by 14 C1, 11 by 14. This also I told you why 11 by 14, because the orange which is drawn first kept outside, you don't kept again in the box. Therefore there are 14 total, 14 oranges are there, we have to draw one, and good apple one already gone, so 11. Third also good apple means 10, that's why 10 by 13. So together, so required probability, all three are good oranges means P of A into P of B into P of C, and we got it 44 by 91. Okay, my dear students, you got this. So this is the problem number 3 we did now. Let us move to the problem number 4 now. Okay, okay, good. I think you understood now. So you have to, theoretically you should think, otherwise problem will come. Okay, anyhow, next problem. So what is given, I'll tell you. This is minimum writing, I am telling you. So minimum you should write. Simply we cannot live like this. Okay, na? Okay, let us move to the next one. So for problem number 4, because already 1 2 problems we explained, 6th from onwards we did. 3 4 5 I think we left over because of theoretical. Now we are doing that. Okay, so 3 is over. Let us move to the 4 now. Let us move to the problem number 4. A fair coin and unbiased die are tossed. Let A be the event, head appears on the coin, and B be the event, 3 on the die. Check whether A and B are independent events or not. Everything he is given. Very good boy. He is already given what is the statement, he need not worry about it. So what he did, first of all, you say, a fair coin, you write that. Okay. Over. So that is the first important thing, what you have to write means, a fair coin. So what is, he has given first, let us write, a fair coin. A fair coin and an unbiased a fair coin and an unbiased die are tossed. Die are tossed. Tossed. Okay. So first of all, how many sample points are there? Let us know first. So a fair coin and unbiased. Why I said fair coin means, if you toss a coin, you should get either head or tail. You should not say to stand in between, sir. Neither head nor tail, like that is there. You should not say like that. That's why fair coin is said. Before only he said you will get in your mind like that thinking, that should not be there like that. He said fair coin. Unbiased. This is also same. So there is no chance of getting 1 is more number of times, 3 more number of times like that. Unbiased is everything is equally likely. So like that is there. So what is N of S? First, number of sample points in this. So a coin means coin is tossed, die is tossed. So how much will be there? I'll write here. The chances are head 1. A coin may appear head and die may be 1, or in coin only head, die may be 2, or H comma 3, head comma 3, again head comma 4, again head comma 5, again head comma 6. This is one way. Why head only? Tail comma 1 means tail comma 2, like that tail comma 3, like the tail comma 4, like the tail comma 5, like the tail comma 6. So total how many are there, my dear students? N of S. This is S. This is sample space. So N means number. N means number. So N of S is equal to 12. 1, 2, 3, 4, 5, 6. 6 plus 6, 12. N of S is equal to 12. That you got. There are 12 sample points in a given experiment. That is tossing a coin and throwing a die both together, which are fair and unbiased. Okay. Next, what is given? Next point, let us see now. Given, we will write like that only. Given, A be the event, capital A. Okay. A be the event. Given, A be the event. Head appears on the coin. I'll write there. Head appears. So here what is there? Whatever textbook is there, that only you are writing. You need not to write anything. Head appears on the coin. But you should write. That is important. Head appears on the coin. Okay. Let us see now. What is event A? Given A be the event, head appears on the coin. That is given. Otherwise, let. Normal given means you something you will think. Let A be the event, head appears on the coin. Okay. First of all, let us write the sample bits. Head appears on the coin means he wants head must be there on the coin. All 6 will come head. You see, H1, H2, H3, H4, H5, H6. So this is there first. This is all head appears on coin. Okay, na? So N, this implies what is N of A? N of A is equal to 6. Okay. So this implies what is P of A now? P of A is equal to N of A by N of S. Means N of A is 6 by 12. That is equal to 1 by 2. He is asking independent or not means probability of A we have to find out. So P of A is 1 by 2. Here see, N of A is 6, N of S 12, 6 by 12, 1 by 2. Okay. Now what is B? event is given now, and he has given and B be the event, and B be the event, and B be the event, the number is red. And B be the event, 3 on the die. 3 on the die. This is given. 3 on the die. So this is problem number 3. 3 on the die. So 3 on the die means what is sample points are there? Right. So 3 on the die means what is there? Head comma 3. Yes, 3 on the die. Tail comma 3. That's all. Only 2 are there. Head comma 3, tail comma 3. Then no other 3 are there. So over. Now A intersection B. What is A intersection B, Amma? It is 3 must be there and head must be there. Head and 3 together. Correct? Huh? So head and 3 together means what is there? You tell me. Only H comma 3. So that is nothing but 1. So that is H comma 3. This implies N of A intersection B is equal to 1. Here this implies N of B is equal to 2. This implies P of B is equal to N of B by N of F. Everything I am writing because you have to write an exam. That is the reason I am writing everything. 2 by 6. Sorry, 2 by 12. 2 by 12 means how much? 1 by 6. The probability of B is equal to 1 by 6. Now N of A intersection B is equal to 1. This implies P of A intersection B. What is P of A intersection B? N of A intersection B by N of S. N of A intersection B 1. 1 by 12. Okay. Now he is asking whether the events are independent or not. So what we will learn? Independent events means first beginning. 2 events are said to be independent. Their intersection, probability of their intersection is equal to the product of their probability of individuals. Means this implies P of A intersection B must be equal to P of A into P of B. This is the condition. When this is satisfied, we can say A and B are independent. So what is P of A intersection B? P of A intersection B is equal to 1 by 12 is equal to P of A. How much? 1 by 2. What is in P of B? 1 by 6. 1 by 2 into 1 by 6. 1 by 12. Both LHS RHS satisfied. So this implies given two events are independent. That's all. Independent events. Given 2 events are independent. How we got independent means, okay, 1 by 12 is equal to 1 by 12. That's why it is independent. Correct or not? If they are not equal, that is not independent. So we can say like that they are not independent events. Here satisfied, hence we can say they are independent events. Okay? Let us now, we'll move to the next problem. Problem number 5. Because we did 3, 4 over, now we'll go to the 5. Okay, na? My dear students, understand very clear here. N of S, everything I wrote, you got it. Okay. Let us go to the next problem. Problem number 5. So, why I am writing means at least some problems if I write means some problems you learn. That is what I am telling. Only values if you put means you won't get marks. So, whatever is given here, you have to do it. Okay, anyhow, now let us go to the next one. Problem number 5 now. What is the problem number 5? We'll see now. A die is marked 1, 2, 3 in red and 4, 5, 6 in green is tossed. A die marked 1, 2, 3 in red and 4, 5, 6 in green is tossed. Let A be the event, the number is even, and B be the event, the number is red. Or A and B are independent. Again you are asking independent only. Again you have to find out P of A intersection B, P of A and P of B, and you have to see whether they are equal. if they are equal independent, otherwise not independent. Okay. So from the given statements you have to prepare those things. That's why this is very important things. So first of all, what work is done here? You see, a die is marked 1, 2, 3, marked 1, 2, 3 in red, and 4, 5, 6 and 4, 5, 6 in green. So now green is tossed, is rolled. Toss we cannot use. Coin means you can say toss. Die means better roll, we can say like that. Because die is there means we will roll like that. Coin means we will toss like that. That's why instead of saying die toss, we can better to say is rolled. So now you tell me from the given statement, you leave it of black and green, red and green. First what happened? A die is there, it is rolled. That's all. Correct or not? So a die is red, it is rolled. How many chances will be there? 6. That's all. So first of all, this implies n of s, number of sample points are 6. But what happened? In that 6, 1, 2, 3 numbers marked with red color and 4, 5, 6 marked with green color. That's all. We need not to worry about it. Okay, you should keep in your mind 1, 2, 3 comes is red, 4, 5, 6 means green. That's all. Okay, na? So number of sample points is how much when a die is rolled? 6. In that 1, 2, 3 are red color and 2, 4, 5, 6 are green color. Now, what is event is given? Let us see now. Here is said. What is said? Let A be the event. Let A be the event. The number is even. The number is even. The number is even. Okay. Even means even number. It means that let A be the event, the number is even. Okay, no problem. So first, because I told you, don't read total, don't do everything simultaneously. One after the other, you do it. So it will become easy for you. So first your event is what? Let A be the event, the number is even. Okay. So what are the chances? A is equal to sample points. What are the sample points? Even numbers are sample points. When a die is rolled, what are the chances? 1, 2, 3, 4, 5, 6. In that even numbers are what? 2, 4, 6. That only write here. 2, 4, 6. That's all over. A is equal to 2, 4, 6. Because what is A? Event. Red, green, you do not think. He is having only even number. Even number is 2, 4, 6. This implies n of A is equal to 3. This implies P of A is equal to n of A by n of s, which is nothing but n of A by n of s, which is nothing but 3 by 6. That is equal to 1 by 2. Okay. We got probability of A is equal to 1 by 2. Correct? Over. Now, what is B now? Now you see the B. Here B, what is said means we will see now. B and B be the event, the number is red, and B be the event and B be the event, the number is red, the number is red, and B be the event, the number is red. Okay. Now he is asking what? Red only, colors is asking. Now you should concentrate on colors. Okay. And B be the event, the number is red. Okay. Red color numbers we want. Okay. So B is equal to, what are the red color numbers you tell me? A die is marked 1, 2, 3 in red. So red color numbers are 1, 2, 3. You write that's all over. We don't want green, you write red. So this implies n of B, how much? 3. So what is P of B? This implies P of B is equal to n of B by n of S. What is n of B by n of S? 3 by 6 is also 1 by 2 over. Now A intersection B. Now A intersection B. My dear students, what is A intersection B? It is a red even number. A is even, B is red. So what intersection is common? Common means what? Red even number. Okay. Red even number, what is there? red numbers are 1, 2, 3. In this even number only 2 is there. So only 2 is called red even number. Red color must be there, even number must be there. So that is only 2. So this implies n of A intersection B, how much? 1. Only one number is there. So this implies P of A intersection B is equal to n of A intersection B by n of S. Okay. N of A intersection B by n of S, which is nothing but 1 by 6. Because A is equal to 6, you know. N of S is equal to means 1 by 6. N of A intersection B 1 by 6. Now, what you will do now? P of A intersection B is equal to P of A into P of B or not, we have to check. So what is P of A intersection B? 1 by 6. What is P of A? 1 by 2. What is P of B? 1 by 2. 1 by 2 into 1 by 2 cannot be equal to 1 by 6. So this implies A comma B are not independent. A comma B are not independent events. Independent events. Over. Like this you should say. This implies not satisfied. So A comma B are not independent events. My dear students, you understood, you know. So what is whatever I said theoretically. So first you have to read the problem. Then you should say which is A, B, C. Or A means B means what are the events and their probabilities, their common, and then check. We had A intersection B is equal to P of A into P of B. So before in last class what we did, already that fellow is given P of A, P of B or N of E, N of S, like that we have checked it. Now we are preparing ourselves and we are checking it. That's why it is little more important than the problems which you have given last time. Therefore, this is how we got it. Intersection is not satisfied. Therefore, A comma B are not independent. Not independent events means they are dependent events. Okay, my dear students. So we have completed 1, 2, 3, 4, 5, 6 and 7 also we did. 8, 9, 10, 11 I think so. I have given homework for you. Okay, na? In that, my dear students, I think you may have one doubt in that 11th homework. So that we will see now. In homework 11th problem, 1 A and B means you know P of A intersection B. P of A and B is nothing but P of A intersection B. That you know it. So he has given already the 2 independent events means P of A into P of B. P of A value given, P of B value given. You will multiply over. That you know everybody will do it. So next P of A and not B. This is there. Second bit. 11th in second bit. Probability of A and not B, like that is there. Not B. This implies what? This is nothing but a P of A and means intersection B complement. Not complement. Generally complement how will write now I said it is like this bar. You write like that only. Don't change each and every time. So P of A intersection B complement. What do you mean by P of A intersection B complement? Means this is nothing but I will write you P of A minus P of A intersection B, then it is B complement. My dear students, you see this. So now, because which are the option, which problem is given for you, in that I am asking you. Sir, once again how you got also you can explain, no problem. See now, I will put like this. So here total sample space yes is this and this is A, this is one event. This is another event whose name is A here, A is B here and this is called A intersection B. Now this is called what you know A intersection B complement. This is called B intersection A complement. Because this place B is not there, A is there, B is not there, that is common. Here B is there, A is not there, that is common, that only common is there. So A intersection B complement, dash means here I will put again you will get doubt. Okay. A intersection B complements total is how much is there? P of A, I wrote P of A minus what portion you don't want? A intersection you don't want, remaining only A intersection B complement, this one. So therefore P of A minus P of A intersection B. I think you understood my dear students. So what is P of A is given 0.6 minus P of A intersection B wants P of A into P of B. Correct or not? So P of A 0.3 into 0.6. Okay. P of A into this is 0.3. P of A is equal to 0.3. P of A intersection B independent. P of A into P of B 0.3 into 0.6, which gives 0.3 minus 0.18. 6 3s are 18. Here decimal point 1 digit is there, here decimal point 1 digit is there, and you multiply, you should add it. So after decimal point 2 digits, 0.18. So this implies what? 0.30 minus 0.18. Nothing is there, means 30. In 30, 20, 18 goes is how much? 12. So 0.12 is the answer. My dear students, if you have doubt, this is the problem. Remaining P of A or B, you will do it. P of A or B means what? Either A or B. A union B. You know formula. P of A plus P of B minus P of A intersection B. You know very well, you will do it. Next one is what is given now. The fourth bit. I will see this. This also I will explain you. P neither A nor B. I think if you have any doubt, means these two problems only you may have it. Okay na? So that's why again I got doubt. I think you people might be in worry how it has come like that. A union B, intersection B, you know already first bit also explained here. 0.3 into 0.6 is 0.18, first bit only. So first is over, second is over, third is you do it A or union B. Now fourth bit I am telling you here. In this fourth bit what is given? P neither A nor B. So P neither A nor B means what, you know? P of A complement intersection B complement. That is the meaning. Neither A nor neither A nor B. P of A complement intersection B complement. That is equal to. So 1 minus P of A union B. Direct and right. P of A bar intersection B bar is equal to P of A union B whole complement. This is nothing but P of A union B whole complement. Again A complement means S minus A. S means total. Total means 1. So 1 minus P of A union B. That's all. So 1 minus what is P of A union B? Third one you have to find out. If I do means all the bits I did only. So P of A plus P of B minus P of A intersection B. That is only third. So third also I am doing means everything I did here only. So 1 minus what is P of A? 0.3. 0.6, 0.12 because already we did here. So therefore, no, not sorry, 0.18. This is P of A and B bar. This is A and B means P of A 0.3 into 0.6, 0.18. So 1 minus 0.9, 9 means 90 minus 0.18. My dear students, this is nothing but 1 minus 0.72. 90 minus 1872. 1 minus 72, 0.28. In 1, if you take 100, if you remove 7.1 means how much will come? 0.28. So 0.28 is the answer. This is important problem. I think 100% you might have followed this. Okay. So this is also we have completed. So up to 11 problems is over. I think 12th problem we have to do. I feel so. Otherly I did, I'll see now, I'll see and tell you. So, exercise each and every problem we are doing now, that you have to observe now. Why means to make you learn each and every problems are doing. Problem number 12, yes. I don't know. A die is tossed thrice. Find the probability of getting an odd number at least once. I don't know whether I taught or not, but anyhow. Once again we will do it, no problem. So my dear students, okay, so here let us go to move to the problem number 12 now. In this problem number 12, a die is tossed thrice. Find the probability of getting an odd number at least once. Okay. Here the problem. Here you have to see now. Okay. Now, my dear students, here a die is tossed. A die is rolled. I told you. A die is rolled thrice. Thrice means 3 times. One time if you roll a die, what are the sample points? 6. So this implies n of A is equal to 6 into 6 into 6. First time 6, second time 6, third time 6, all happening simultaneously. This is nothing but 6 cube, this is nothing but 216. So, when a die is rolled thrice, the number of sample point are 216. Okay. Now, what do you want? That is the important thing now. What you want is, let E be the event. Let E be the event getting odd number at least once. We will write like that. Let E be the event. E be the event of getting odd number at least once. My dear students, let E be the event of getting odd number at least once, because that question is asking like that, that only know. Find the probability of getting odd number at least once. That I said E be the event of getting at least odd number at least once. So now what is E bar complement? And you write here, and E bar be the event of getting 0 odd number means what? Not getting at least also one odd number. That is called 0 odd number. 0 odd number means what? Not getting at least one. At least means what? 1 and above. In 216 cases, 1 and above, getting odd number of more than 1 means, for me it is very difficult. So much I had to do. So immediately I thought, which are not at least 1 above? What is 1 below? 0. Getting 0 odd numbers, if I find out, I can get the other way, the probability of getting at least 1. So you have to see like that. When event is more difficult, then complement you have to find out. So through complement, you can find out like this. That's why let E be the event of getting odd number at least once means, immediately what I said, and E bar means complement, be the event of getting 0 odd number. So 0 odd number, if you find out this probability and you subtract it, you will get it. So that is how many will be there? That implies n of E bar, E complement is equal to, here also more will be there, I can write this. N of E complement is equal to 3 into 3 into 3. My dear students, 0 odd numbers means all are even. Correct? Huh? 0 odd number means what? All are even numbers. So when a die is rolled, how many even numbers are there? 3. How many odd numbers are there? 3. So 0 odd numbers means what? 3 even numbers. So first time if you throw a die, 3 0 odd numbers will come. Second arm also same. Third arm also same. So 3 into 3 into 3, how much? 3 cube, that is how much? 27. This is the probability of, number of odd numbers, 0 odd number getting. What is its probability now? P of E bar is equal to N of E bar by N of S. What is N of E bar? N of E bar 27, N by N of S 216. In 27 by 216 means you can see how many times goes. 3 goes, 9, I think 3 9s are 27. Okay, 2 9s are 18. 36, 4 9s are 24. Again 3 goes in 24, 8 times means 1 by 8. 1 by 8 is the probability of E complement. Now, what do you want? You don't want this. What do you want now? You want that required probability. What is required probability? Required probability is P of E. That I want. What is the E be the event of getting odd number at least once? That I want. Because already we learned first year also. So P of 1 complement we know P of E is equal to 1 minus P of E bar. Correct? With that we got it. See how simply got it. So therefore, probability of getting at least 1 is nothing but 1 minus its complement. So 1 minus its complement means what? 1 minus 1 by 8. How much you will get? 7 by 8 is the answer. So probability of getting at least one odd number, at least once is 7 by 8. So that whenever you are not able to find out number of sample points, more comes, you have to go to complement and find the probability of complement, and you are subtracted. Why you are subtracting from 1? You know the probability of failure plus the probability of success always be equal to 1. That's why if you know success complement, P of E bar is equal to 1 minus P of E. In the similar fashion, P of E is equal to 1 minus P of E bar. That you know fundamentally already we have studied in first year. So that's why I did immediately, whenever you want to find out this, immediately I go for a complement of it. I find the complement probability. The finally I want P of E, which is nothing but P of E bar. I got a very simple manner. That is how we have to think and we have to do. Okay, my dear students, let us move to the next problem. Problem number 13, I think so. 13. Okay, na? Shall I repeat everything? Okay. Now, we will go to the problem number 13 now. So, if I don't write this working means, I would have completed by this time, everything. But what is the use if I don't write, you also don't write means tomorrow marks will go. Probability and permutation, combination, everything should write, steps are required. So that is the reason I am writing each and everything. Okay, anyhow, now, no problem, one more class extra will come, 1-2 classes, no problem, what is there? Okay, now, let us see the problem number 13, 12 is over now, 13. Problem number 13. 2 balls are drawn at random with replacement from a box containing 10 black and 8 red balls. Find the probability both balls are red. First ball is black and second is red, and one of them is black and one other is red. Like that he has given. Okay. So that is what is given now here. It doesn't matter, we will do it. So you want, what you want is set a box, I will write here first. 2 balls are drawn at random with replacement from a box containing. So given a box containing, what is in that box? What is there? A box containing 10 black balls, 10 black balls and 10 black balls and 8 red balls. That is how the box is there. A box containing, given a box containing 10 black balls and 8 red balls. Okay. Now, find the probability that both balls are red. First bit, 3 bits are there. Both balls are red. Okay. So, you can write, let A be the event. Let A be the event of drawing. Event of getting, you can say like this, event of getting 2 red balls. 2 red balls when balls are replaced. When balls are replaced. Because he has given, replaced like that. So he is not given means different will be there. I will see now. Once again I will check. Find the probability. 2 balls are drawn in front with replacement. Yes, with replacement. He has given with replacement. And the ball which was drawn first, again he kept inside. Okay. Now, let A be the event of getting 2 red balls when balls are replaced. Okay. This implies, what is probability of A now? Now, what is happening? Is drawing 2 balls from, not at a time, one after the other from the box. First, he put his hand in the box. How many balls are there in the box? 10 plus 8. 18 balls are there. So, first of all, the chance of getting 1 ball from 18 is 18C1. Over. Then N of S. N of S. So, N of S means total balls are 18. If I draw 1 ball, chances are 18C1. Any one of the 18 balls will come. That is called 18C1. NCR. Selection or election can be done in NCR. Okay. What is your event E? What balls you want? You want red ball. So how many red balls are there? 8. So out of 8, 1 red ball will come, because you won't take black ball, no use. So you want red ball means you should come from 8 only. The chances how much is there? 8C1. So 8C1 by 18C1, which is nothing but 8 by 18. Let it be like that, or you can simplify. That is up to you. 4 by 9. 4 2s are 8, 9 2s are 8, 18. Okay. This is the probability of drawing first draw. Into, I will write here. Simplification I won't write, I will write here. Into, afterwards I will simplify. 8C1 by 8C1. Now second ball also red only. The ball which you have drawn, whether kept outside or inside? Inside only, not outside, replaced. Therefore, how many balls will be there again? 18. How many chances are there to draw it? 18C1. So here also 18C1. No problem. Here how many will be there? Again 8 red balls are there. Again getting a red ball is 8. This is called independent events. So therefore, how much you will get now? 8 by 18 into 8 by 18. That is nothing but 4 by 9 into 4 by 9, correct? 4 2s are 8, 9 2s are. That is nothing but 16 by 81. The probability of drawing 2 red balls with replacement of the balls is 16 by 81. That is the problem. A, what is A? Let E be the event of getting 2 red balls when balls are replaced. Okay. Now bit 2. What is bit 2 is given? Let us see now. This is bit 1. My dear students, this is bit 1. What is bit 2? We will see now. First ball is black and second is red. So let B be the event of getting first ball. First ball is black. First ball is black and second is red. And second is red. Okay, no problem. He has given now. First ball is black and second is red. Now you see. So what we will do now? So probability of B is equal to first ball is black is given. First ball, whatever ball you are drawing, that should be black only. Happy. First ball is black. So how many blacks are there? 10. Total balls how many are there? 18. That is common, 18C1. First ball black must be there means out of 10 should come. So 10C1 over. Into, when you are going, ball is replaced only, no? Okay, when you are going for second ball is what? Red. Now here also how many will be there? 18C1 only, because ball is replaced. But red balls how many are there this time? 8 and 8C1. So getting black ball first, getting red ball second is like this. So how much you will get now? 10 by 18 into 8 by 18. So 10 by 18 means what? 5 2s are 9 2s are 4 2s are 9 2s are 20 by 81. So the probability of getting first a black ball and second is a red is 20 by 81. What is the third bit now? You will see now. 3 bits are given in this. 3 bits means 3 problems, that's all. 3 bits means 3 problems. What is third bit is given? Let us see now. In this third bit, what they said, we will see now. One of them is black and the other is red. Let C be the event. Let C be the event. Like that working you should write. Let C be the event of getting one of them is black. One of them is black. One of them is black and other is red. And other is red. One of them is black and other is red. Now you see. Sir, what is the difference? Here also black and red, here also black. Yes, there's, see. Here he said first ball is black. Here he is saying one of them is black. One of them is black means what? When you draw 2 times, first ball there is no necessity that first ball only should black come. First ball may be black, second ball also may be black. So 2 times you have to find out chance. Here particularly given first ball black, second ball is red. Here is not given. In 2 draws, I want to get one black, one red. That's all. So getting one of them is black and other is red. So this implies P of C. How will see now? So for example, first we got black only, means same story. 10C1 by 18C1. In the second red means 8C1 by 18C1. Now another girl will say, no sir, why first black, first red only? Okay, or how will say, first black we got it, we don't, or means what? Plus, and means what? Into, or plus. Okay Amma, as you said, first draw is red only, then how much problem? 8C1 by 18C1. The second box is what? Black, and 10C1 by 18C1. No difference, same only. No? 2 times you have to put 2 into. So this implies, already I substituted here, simplified here, that's why 20 by 81 into 2 times. Here the same we are adding this 2 times. So therefore this is nothing but 40 by 81 over. This is 40 by 81. So getting first black, second red is 20 by 81. Getting any one of them is black, one other is red means 40 by 81. You must very carefully here. So particularly given like that means chances you have to find out. So first may be black, second may be red, or first may be red, second may be black. Those 2 problems you should add. That's why this is the important. Okay na? This is the problem number 13. We did it. Now we have 14, 15, 16. 3 problems are there. I'll complete the 14th problem. We'll do the 2 problems next and we'll go for the next one. So here I'll write the 14th problem, my dear students. 13 over. This is your problem only. Probability of solving specific problem independently by A and B are 1 by 2 and 1 by 3 respectively. If both try to solve the problem independently, find the probability that the problem is solved. Exactly, one of them is solved problem. So this is what happened. So now teacher will take like this. Teacher given one problem to us. To us means 2 people. Who are the 2 people? A and B. I'll write here because working place is needed. I'll write here. So there are 2 students are there whose name is A and B. But their capacity also will be there, the student capacity that is given. So now I'll write from that first. What is that? Probability of solving a specific problem. 14th problem. Probability of solving a specific problem. Solving specific problem. Specific problem. Specific SB. Here, FIC, both. Specific problem. The probability of solving specific problem independently, and they don't have any common, that the A will do separately, B will do separately. Probability of solving specific problem by A, the P of A is equal to how much? 1 by 2, and P of B, probability means P of B is equal to 1 by 3. This is given. This first of all you should write. Okay, is already given. Respectively means first year, that is next year. Means what? The capacity of the A person, when 2 problems are given, he will solve 1 problem. That is the capacity of A student. The capacity of the B student is what? Means if you give 3 problems, he will give one problem only. He can solve 1 problem. So that is the capacity of B. So A capacity is 2 problems given means 1 problem he will do. B capacity is 3 problems given means 1 problem he will do. So P of A is 1 by 2 and P of B is 1 by 3. Now is what is asking, if this problem is given to 2 and you must be as a 1 unit, but you must be your unit, 1 section. A and B I put as 1 unit. Okay na? Then I have given 1 problem to both of you. What is the probability of solving? The problem is solved. Bit 1, number 1. The probability of problem solved. Probability of problem solved. Now what is given? The problem is given to both of them. Now both of them is one unity. Okay, na? Now they are, any one of them is tells also, no, chances you have to find out. Means what? Here this is nothing but this implies P of A union B. What? How sir? How you are say? If A do, B don't do also no problem. If B do, A do also no problem. If both can do means no problem. So that's why P of A plus P of B minus P of A intersection B union. Any one of them means R. R means A and B. So P of A plus P of B minus P of A intersection B. Now tell me what is P of A? Here already it is 1 by 2. What is P of B? 1 by 3. What is P of A intersection B? 1 by 6. How do you know, sir? They are independent. They are independent means intersection, what will happen? Product. P of A into P of B. 1 by 2 into 1 by 3. Brain must be sharp. Okay. So therefore, what is LCM? 6. In 6, 2 goes 3 times. In 6, 3 goes 2 times. In 6, 6 goes 1 time. 3 plus 2, 5. 5 minus 1, 4 by 6 is equal to 2 by 3. If the two people together solving the problem means the problem solved is chances are 2 by 3. If two people sit together and they'll solve the problem means out of 3 they'll solve 2. That is their capacity. Together means their sit means. Okay. Now what is the first bit? What is the second bit? Exactly one of them solves the problem. Second bit is given now. In the second bit what is said? Exactly one of them will solve. That only I want. What does it mean is said? I'll write. Second bit. Probability of solving a problem exactly by one of them. Exactly by one of them. Okay, no problem. What is exactly by one of them means what? Theoretically, how can it? P of A union B, A intersection B complement union A complement intersection B. That is the meaning. A complement A intersection B complement union A complement intersection B complement B. What does it mean, sir? Okay, exactly one of them you have to solve means what happened? A will solve, B cannot solve. Or union means or A cannot solve, B will solve. This is the meaning. But both A and B are independent events. I told you, one theorem also is there. If both are independent events, their what is there? Their complements also independent events. So this means, how can you write now? P of A into P of B bar. R means plus P of A bar into P of B. This is the meaning of that. This is the meaning of this. What is P of A? P of A 1 by 2. What is P of B bar? P of B bar means 1 minus P of B. P of B how much given? 1 by 3. 1 minus 1 by 3. Total probability 1, you know. I will write for the one step 1 minus 1 by 3. P of A bar 1 minus 1 by 2 into P of B 1 by 3. Because probability of success and failure is 1. Whenever you want other one, 1 minus you have to do. That is the meaning of that. Okay, now that implies 1 by 2 into 3 minus 1, 2 by 3 plus 1 by 2 into 1 by 3. 1 by 2 into 1 by 3. So here what happened now? 6, let it be, don't cancel. 6 is LCM. 6 is LCM means both 2 plus 1 will come. So 3 by 6, 1, 50%. So the problem, any one of them is solved means 1 by 2. Okay, na? The problem solved by any one of them is 1 by 2. Okay, my dear students, we have completed up to 14th. 2 problems more are there. Well, next class we will do it. Before that, you go through all the problems of 13.1 and 13.2. Be ready. Each and every day you should practice. Otherwise, probability will, now while teaching it will be okay. afterwards you will forget means that's all. Again you cannot remember all these things. So practice makes man perfect, the true movement. Okay na? Thank you.